With no further ado, Mike Ruth.
Thanks, everybody. Yeah, thanks for coming. So my name's Mike. I'm a security engineer over at Rippling, and today we are talking, or I will try to talk. I apologize ahead of time for my voice. We're going to be talking about attacking and defending software supply chains, how we got admin in your cloud environments again. And I say again because this is actually an extension of a talk that I gave in 2022. It was focused mostly on Terraform, so we're going to actually be extending that to a handful of other tools in our CI/CD pipeline. So let's get into it. So what I want to start with is really why do we use software supply chains, and why do we use CI and CD tools at all? And the reason ultimately, it stems from the growth of our engineering workforce as a forcing function to continue to maintain productivity and success. So a company of 20, they can get away with having things like production credentials on their engineering laptops. They can get away with building the artifacts that they need and deploying those into their prod environments. You know, they can get away with actually taking those images and deploying them into the environments as well. But as a company grows, 100, 500, 1,000 employees, this becomes kind of impossible to do without teams stomping over one another. And the need to have these actions performed through automation, right, through our CI/CD tools becomes required. With this, we get a couple of security benefits, and one of them is that we can take those credentials that have been sprawled across all of our engineering endpoints, and we can remove them, and we can have these individuals focus on working with the tools that they're most familiar with, right? Which is things like GitHub, version control, things like that. Now, usually when we talk about software supply chains and software supply chain security, we usually speak to the upstream open source contributors, the libraries and the software that we pull in to our organization from those sources. But the scope of this talk takes a slightly different approach. This approach instead looks at the most common services that we use in our CI/CD tools and the organizations that use them, and how we take software from source to production with those tools. So to start, let's talk about the reference architectures for these tools. And we'll start with GitHub. I won't spend too much time here. I think most of us are probably pretty familiar with GitHub. One thing I really want to call out, we spend a lot of time working with repositories, right? And our repositories are this logical boundary that holds all of the source code for a given service or product. We have another logical boundary if we use something like GitHub Enterprise, right? And that's our organizations. And organizations are this superset, right, of all of our engineers and all of our repositories that exist in one place. This is relevant because we have access control for our repositories. These are, things like managing collaborators who can write, push, create new branches, things like this. But we also then have scalable mechanisms on our org for all of our repositories, and that's what organizations allow us to do. If we think about how we use GitHub in these pipelines, we spend the most time interacting with repositories themselves. And so when creating a repository, here are some things to take into consideration. First and foremost, if you are in sort of the beginning stages of your engineering function and your engineering maturity, 50, 100 so employees, chances are your repositories are going to be allowed to be manually created by most of your users, right? This is good for developer experience. It means they can create any repository that they want. They can move quickly. In doing so, this gives them the ability to configure all the settings for that repository. This is things like manage collaborators who can get access, configuring webhooks, protection rules, right? Making sure that you can't force push to main, things like this. The other thing it means is it can actually configure how you connect to the rest of the tools in these environments. So with that, we'll move to the next set of tools that we're going to look at, which is GitHub Actions. Probably the easiest tool to use with GitHub since it's just natively supported. And the way that this works is through workflows. So workflows run a set of jobs on a repository basis. Each job runs in its own GitHub worker, so that's like its compute, dedicated compute. And it's configured on a reserved file path in that repository, the .github/workflows repository. So any YAML files that exist there, they are going to run as jobs. For those workflows to be able to do anything, they need to reach out to the outside world, right? And so they do that with an identity of the worker. So this is a GitHub token that actually gets provisioned and put in the GitHub worker itself. the GitHub Actions worker. And so this allows them to get access to things like GitHub secrets, repository secrets, org secrets, things like this. But perhaps more recently, and a bit more elegant of a pattern, is it allows you to actually federate between your GitHub repositories into your cloud environments using things like OIDC and the integrations that exist there. The GitHub Action workflows are triggered through specific events that you might be familiar with, on push, on pull request, on merge, things like this. We can see an example of that on the right. So this is saying, hey, whenever you see a pull request to this given repository and it modifies the specific paths that are defined, go and check who's actually performing that change. And if it's one of these individuals, like these robots, allow it. Otherwise, let them know, hey, we shouldn't be actually modifying these paths. They're reserved. This is probably good for like an open source contribution, an open source repository. Okay, let's look at another continuous integration tool, BuildKite. BuildKite, very similar to GitHub Actions. Instead of using workflows, it uses pipelines. And pipelines are configured in much the same way. You'll have a YAML file known as a step file deployed in a reserved path. This is the .buildKite path in your repository. Also triggers based on the same types of events. Unlike GitHub Actions, it does require integration, so you do need to set up a webhook for this to work. And it uses an identity much like GitHub Actions workers do or workflows do. In this case, it's an agent. So the agent is the identity for a BuildKite pipeline, and it has access to all of the secrets that you would expect that GitHub Action token does. You would get access to things like IAM roles, service accounts, any sort of secrets that exist in the secrets manager of your choice. And we can see an example of how a BuildKite pipeline looks on the right. This is just an example where you can see that the agent is defined, the deploy artifact to a prod agent, and that allows you to then assume a specific role and then run some sort of script that will build your image and push it. So let's go over our reference architecture after we've gone through some of these tools. So this is sort of a step-by-step flow that you might see a user perform to actually use some of these tools to deploy from source to production. So step one, you have a user and they want to perform some sort of modification. So they submit a PR to your given repository based on the configuration files that exist, the BuildKite YAMLs, the GitHub Action workflow YAMLs. They may trigger a job or a webhook of some kind, which then is fetched and run on a given worker. So that's steps 3 and 4 here. The workers then have their identities. They can go and fetch all of the secrets that allow them to perform any sort of actions that they need to perform. At step 4, this is sort of the pre-plan phase. So these are things like CI, linting, testing, integration, things like this. At this point, there's some sort of code review that's going to occur on the PR. They're going to look at all of the builds that have run, given a +1 to make sure that everything is working correctly. And then once it gets merged, we'll see step 5, some type of write-based action will occur, like building artifacts and pushing them, say, to a artifact repository or objects into object storage. The next tool in our reference architecture is related to continuous deployment. That's probably worth noting that GitHub Actions and BuildKite can also be used as continuous deployment, but I think more often they are associated with continuous integration. Here we have Terraform, and this is how Terraform works, at least for the paid versions. If you're using a free version like Atlantis, it will have most of these things in common. The first thing actually is something that it doesn't have in common. So we can sort of see a pattern with all of these tools that they have some sort of logical boundary that exists. Organizations, workspaces, and so with workspaces in Terraform, they're responsible for maintaining state and all of the resources that you want to change. So if you're trying to modify AWS resources, you might have a workspace that's dedicated for doing that, and those workspaces are associated to a given repository one-to-one, or maybe a subdirectory in your repository. So you might have a Terraform repo, subdirectory for dev, a workspace for that. You might have a subdirectory for prod, a workspace for that, and so on and so forth. In these workspaces, you have state files. The state files are responsible for, as the name implies, managing state. So it will know the last known good configuration that your workspace has pushed up, so that any incoming changes will then provide you a diff when you perform something like a dry run or a plan. This is very good for code review. Next are providers. Providers are doing all the heavy lifting here for Terraform. So this is a plugin. It's a binary that runs on the worker, and it knows how to interact with all of your the the resources that you're trying to manage. So if you're managing AWS or GCP or Azure or Kubernetes, these providers are going to know the endpoints that they need to reach out to. They're going to know the parameters for all of the resources that need to be configured, so on and so forth. And then last, we have permissions. These are how you interact with Terraform. It's also how people and, say, the upstream integrations, like from your version control, are going to do so as well. Very similar reference architecture, right? PR is created from a user, goes to the Terraform repository. That PR triggers a plan, dry run occurs, some sort of code review happens, you get the +1. Resources are then managed inside of your environments. Okay, so we have a couple of assumptions based off of the reference architectures that we've described here. And so one thing that I like to do on this slide, because this is the second time that I've presented it, I want to poll the audience, show of hands. How many people have either currently worked at or at some point in the past an organization that allows all of their engineers to push pull requests or just push code to any of the repositories in their environments? Show of hands. I would say probably 2/3, the majority at least, right? And I think that makes sense. Maybe some of you are being lazy and not raising your hands. I don't know. But most of us, I think, and it makes sense because it's good developer experience. You want people to be able to quickly make changes, and go through this sort of code review process to be able to quickly iterate. All right, second assumption. For most repositories and most organizations, our branching strategy is largely flat. What that means is you tend to have one protected repository, main, for example, and then everything else. So no sort of complex feature branches, just one primary repository, and then any sort of review to push code up to it after a merge. And then the last assumption is that it is predominantly up to service owners to manage their own workflows and pipelines. What this really means is that we are not expecting our infrastructure teams to be performing white glove services for deploying all of these resources. There's an expectation that you might need to perform some actions, or engineers might need to perform some actions to manage them themselves. Okay, so with all of this preface, here's my problem statement. Engineers have access to create repositories, PRs, CI/CD resources unilaterally in our organizations, and as such, they can create and trigger dry runs for new and existing workflows, pipelines, and plans for all of our environments. So why is this a problem? And let's get into some findings. But first, I need a drink. Just a regular drink, not a drink. That's later. All right, findings. So to illustrate the findings that I'm going to talk about, we're going to walk through the creation of some of these resources that we talked about in our reference architectures. So we're going to go through the creation of a repository, we're going to look at GitHub Actions, and then we're going to go through the creation of a build kite pipeline and how we connect those two things, and then we can see some of the issues that might stem from that. So to start, we have the creation. Does that look okay? Yeah, that looks okay. This is such a huge screen that sometimes it just gets stretched out, but I think that's okay. Anyway, okay. On the left side, we have the process of creating a new repository. So this is an example of me going and creating a Technologic temp repo. And then on the right side, once we've created this and gone into the GitHub Actions section and then looked at the secrets, we can see that just by default, it has access to a couple of things. One, repo secrets, by default, they won't exist, so you just have to create them, and that's fine. But by default, it also gets access to all of the GitHub organization secrets inside of your org. So any secret that's defined is given to all repos by default. So, and you might see where I'm going with this, but we'll see why that could be a problem later. Next, we're going to go and create a build kite pipeline. And so what we're going to do is start by going into the dashboard for pipeline, creating that, or for build kite and creating that pipeline. That's going to give us admin to be able to manage it. Again, you have a repository that we've just created. We're going to then connect the two, right? And so we do that through that webhook that we talked about. One thing that the pipeline then needs to do is it needs to be able to fetch the configuration YAML that we've defined in the repository to know what sort of jobs needs to run. And to be able to do that, it needs permission to read to the repo. And you can do that in a couple different ways. You could create a deployment key. You could create maybe a personal access token. Those aren't particularly good ways to do that. You could also go and create a GitHub app and then allow that GitHub app to be a collaborator to read, and then you can give that to your pipelines to go and get access. So what does that look like? Starting with step 1, we see that we have this technology temp pipeline that we've created. We see that it's associated with our GitHub repository. Step number 2 on the right here, we see the conditions for how the pipeline triggers, basically just on pull request and any sort of changes to a pull request. Step 3 is the setting that shows you how to fetch the pipeline configuration. And then step 4 is showing the webhook on the GitHub repo that connects the two. Okay, by now you're probably like, hello, what's the problem, right? If you're any sort of Caddyshack fans, maybe I'm dating myself, I don't know. But we're waiting, right? So let's get into that. So going back to our GitHub Actions use case, we're going to talk a little bit about secrets exfiltration. So we mentioned how the, org secrets are just readily available by default for any new repositories, which means that you can just go and create a GitHub Actions configuration file. In this case, I'm calling it innocent looking file. Spoiler alert, not so innocent. And one of the jobs that it's trying to do is actually exfiltrate or push secrets to the terminal in 2 ways. One in orange, which is just echoing like this org secret. And we can see GitHub does a pretty good job at identifying that you shouldn't be doing that, and they mask it. But the second thing in red, we can actually do a memory dump. And once we perform a memory dump, we can fetch those secrets, base64 encode them, and then we have access to it. And if we decoded this little blob here on the right, what we would find is 2 things. 1, the value of the prod org secret, and 2, the identity, the GitHub token of the GitHub Actions worker, and whatever it can do and get access to. So that's problem number 1. A similar type of problem in BuildKite as well. So what we can see here on lines 1 and 2 is that we can arbitrarily define the agent for our BuildKite pipeline. So by default, any agent for any other repository can be leveraged with any other repository. So here we're trying to use a prod agent, which typically isn't accessible or has no relevance to the repository that we've just created. But then we can go and assume all of the roles that agent has access to. And in this case, we can perform some sort of arbitrary code. And in this case, we're performing a get caller identity to prove that we have in fact assumed that role, and we can see the output of that down at the bottom here. So you might say, Mike, we don't actually allow the engineers in my org to create repositories and pipelines in my org, though. And at which point I would say, okay, excellent. Let's back it up. I think we're done here, right? No. If that were true, I would probably be about as helpful as Tuxedo Mask is to Sailor Moon for any of you Sailor Moon fans. So the next finding, which I think is where we're going to spend most of our time, is on what I've been calling pre-merge remote code execution. And remember back to our first slide where we talked about when we implement our CI/CD pipelines, one of the benefits that we get is we can pull all of those credentials that existed originally on all of our engineering endpoints. We can remove them and instead have teams interact with our pipelines themselves, say through version control. What we see here is documentation from GitHub that says, hey, if an individual has write access to your repository, they in fact have read access to all of the secrets in your repository. So by allowing everyone to actually have read access to the repository, what we're doing is we're effectively removing the intended security boundaries and the intended security controls for implementing these CI/CD tools in the first place. So to my surprise, and also to Pikachu's clearly, GitHub is implicitly saying, hey, this problem is sort of outside of our threat model. So what does this mean? This means that instead of needing to create your own repositories and make those connections, so long as you have the ability to push PRs to any other repository that exists, you can do all of the things that we just looked at, and then a couple of other things too. So GitHub Actions, you can modify existing workflow files in an existing repository or create new ones and then trigger on push all of the attacks. And the reason that this works is because when you go and create a new branch, the configuration files exist in that repository. So if you modify those configuration files and do something malicious with them, they're honored in the pull request itself. They'll just run whatever code you tell it to. And so you can do whatever whatever the permissions are on the identities for those workers, you can actually use those to get access to whatever you need to get access to. So this opens up two new use cases for us. One is the federated OIDC mechanism that we talked about before. So using OIDC federation from existing repositories, and then also being able to use unsafe built-in functions in Terraform, like null resource, run command if you're using something like TerraGrunt, any sort of third-party marketplace or remote-based providers. There's a bunch of sort of nasty things that you can do with Terraform resources. And that allows you to exfiltrate secrets, access state files which themselves might have secrets, and escape to the underlying file system and actually perform Terraform applies. One thing you'll probably recognize here, right, is that Terraform, because they need to manage cloud resources, they have admin already, right? And that means that you can get access to those admin credentials to do, whatever you want to do with those admin credentials. All right, so let's talk about that new use case that we talked about here with OIDC-based federation and how that works. So to set up federation between your GitHub Actions workers inside of a given repository and your clouds, you first need to create a provider for that. And we can see that with step number 1 here. So this is, infrastructure as code. You could do this manually. This is just how you want to configure it. This is for AWS, you'll note, because on step number 2, once you've created an IAM role that you want your GitHub Actions worker to assume and get access to, the way that you do that is you actually create a trust policy, because when your GitHub Actions worker is created and that GitHub token is provisioned for it, what you allow it to do is actually create a JWT, a JOT, and then you can actually translate that into STS credentials for the IAM role. That's what this provider is allowing you to do. And the way that this works is you actually set conditions that say inside of the subscriber claim of that JWT, allow a given repository and a given GitHub org to be able to assume this role. And so it actually honors that configuration. And so that's what the trust policy in number 2 is here. Number 3 down at the bottom then shows you what permissions you need to put inside of the GitHub Actions workflow for this to work. We can see that here. So on the left side, we have an example of how GitHub Actions workflow will allow you to assume a particular role. And then in this case, we're just going to show a get caller identity that actually demonstrates that we have become this actual GitHub Actions role. And again, we can see the trust policy down below. Okay, so that's our first new example. Our second new example is what I call a apply on plan bypass. And so the way this works is that we can actually use the permissions of the Terraform worker and then the resources that we've, the unsafe built-in functions and resources that we talked about a couple slides ago, to actually escape from the context of a plan and go underneath to the underlying file system and perform an apply. And so I'm going to show you how that works on the next slide, but what I really want to do is just kind of show you a fake demo company and the reference architecture that they've implemented. So this is a sort of fake company, Crypto Exchange Co., and they're using Terraform Cloud to manage their dev and prod instances of their website. You can see that as changes come in from GitHub, that triggers plans, and once the plans have been reviewed, +1 and merged, they will deploy resources either to the dev environment or the prod environment based on the environment that's configured. So I have a demo of this that we can see on the next slide here. Okay, so what we're going to try and do is we're going to try and create an S3 bucket. And we can see that the name of this S3 bucket is called remove this test bucket, right here. And so we can first go into our AWS account and confirm that it doesn't currently exist. You can see that it didn't. So we're going to go and create a PR to our Terraform repository. We've created this pull request, and then that's kicked off a plan. And when we go into this plan, we can actually see that our malicious null resource is being created, or the dry run is running it. And inside of that, we actually are performing a Terraform apply. And this apply is complete. You can see that the resources were created, and then we go back into the AWS account, and here it is, right? So remove this test bucket, all within the context of a plan. So there was no code review, there's no merging, nothing needed to happen. We just went and created this resource. So when we go back to our problem statement, anyone who can push or create PRs to a repository can create exfiltrate secrets from GitHub Actions, build kite pipelines, and Terraform plans. They can bypass access control to apply this arbitrary code from unmerged and non-code review PRs, and they can perform secrets exfiltration, privesc, lateral movement to any of the other environments using permissions of our CI infrastructure. Okay, we've gone over some findings. Let's talk about some potential remediations. Hopefully we can do a little bit better than our squirrel friend here in Ice Age. He's trying. Okay. All right, so using the assumption here that it's up to service owners, right, to manage their own CI and CD workflows and pipelines. One thing that we want to do, right, the goal is to make sure that we can continue to keep a good developer experience while also removing sort of the manual creation process by adding some sort of technical gate. So the best way to do this is probably with config as code. This could be infrastructure as code. This could be a developer portal of some kind if you use something, say, like Backstage, a wizard, right? Whatever it is, removing the ability to create those resources themselves by modularizing it so that it can be scalable and secure by default will allow us to maintain that good developer experience. The next thing we can do is use GitHub environments. And so this is particular for GitHub Actions. GitHub environments have been around for a couple years now. And the goal of using GitHub environments is to create an affinity between secrets, the GitHub branch that we want the action to run on, and the actual GitHub Actions workflow contents inside the file itself. And so the way that this works is we can actually define GitHub secrets inside of an environment, and then we pin that environment to the branch and say, hey, only allow this environment to be cross-referenced and leveraged, and then thereby these secrets based on that. So what we can sort of see here is in the picture, we have two different types of environments. We're calling it post-merge and pre-merge, right? Where post-merge can only, and the secrets in post-merge are only accessible by protected branches, which means they can only be accessible in main or in whatever feature branch you might, that you might have. Pre-merge then is accessible by anyone. Anyone who can create a PR can then get access to these secrets inside of these environments. and we'll see a little bit more what this looks like in a couple slides. So we want to do similar for build kite. So we have perhaps a way to mitigate these things using GitHub environments. Instead, let's take a look at build kite and its pipelines. Similarly, the goal is to mitigate the ability to arbitrarily choose any agent and all of the IAM and secrets that those agents get access to by establishing some affinity between the repository, the build kite pipeline, and the agent that it's running as. And prior to February 2024, this was not easy to do. It was only in February of 2024 that BuildKite created this functionality in G8 called clusters, which does actually exactly that we talked about, where we can actually create a cluster, and in that cluster have agents and the pipelines that can use those agents. So then we actually create this affinity like we talked about. So with GitHub environments and with BuildKite clusters, the next thing we want to do is create this opinionated branching strategy. And we talked a little bit about it, right? Where if you have a set of pre-merge environments and a set of post-merge environments, or in this case, they can also be pipelines. Excuse me. We can also then set the credentials and the privileges inside of those all of the branches that make up those pre-merge and post-merge locations, so that pre-merge only has read-only access, and those are accessible by non-protected branches, and post-merge has more privileged credentials and are only accessible by protected branches. And we can see sort of an update of what our reference architecture might look like by implementing these changes, using BuildKite as an example. Two things to call out here. Number 4 and number 3 are kind of where things change, where typically you could sort of define any sort of agent that you wanted here, and you could sort of cheat and cut the line, right? And you could actually perform these build steps and privilege steps and go straight to 7 without any sort of code review, +1 or merging. With this implementation, you can no longer do that. And so with and the same is true for step number 3, you can't arbitrarily choose a new agent and then cut the line and go down to 7 here. Okay, And then this is a bit more of a closer look for GitHub environments. We saw the top piece of this already. Now looking down below, what we can see is an example of the post-merge environment where we say, hey, we have a protected, the secrets that are inside of this post-merge environment can only be accessible from main, right? And this is what it looks like. So if we go back to our GitHub Actions workflow, this innocent-looking file that wasn't so innocent, we try to perform the same type of attack, right? But in this case, we can only access the secrets by defining the environments. So if we want access to those privileged secrets, we have to use the post-merge environment. And we see that in red here, that we try to. And now we see GitHub environments on the top right, which shout out to whoever worked on the UI for GitHub environments. I love these little like rockets and the color coding for whether or not they were successful or not. It's very cool. And we can see for post-merge, the red rocket indicates that it was not successful. And when we go into the details of why it failed, we can actually see here down at the bottom right that our code was no longer allowed to get access to the post-merge environment because of the protection rules that are in place. So that means that our branch can no longer go and get access to the secrets that allowed us to perform secrets exfiltration that we were worried about. This can also be applied to the OIDC federation use case that we talked about as well. So we can actually define environments for our IAM roles. And for the record, if you aren't using AWS, that's okay. If you're using GCP, Azure, other clouds, they all support this federated use case. It's just, GCP service accounts, Azure service accounts, they're all supported. I'm just using AWS here. And so we can see this in the pre-merge use case where our trust policy is updated here on the right, where we have two dedicated roles. Right now we have a read-only role and we have maybe an admin role. And on the right side, we can see on the far right that inside of the claim is a new piece of information that dictates the environment itself. And the same is true for post-merge as well. In this case, we're trying to get access to admin, but we can only do so on specific branches and in specific environments. Okay, so we went through GitHub Actions, we went through BuildKite. What about Terraform? The best way to limit the Terraform plan attacks is to check for dangerous resources defined in the code prior to performing a Terraform plan. I'm not going to get into the enterprise and cloud use cases immediately. We'll see a little bit later. But if you're using an open source version, something like Atlantis, the best way to do this, since you kind of control the whole pipeline, is to serialize all of the webhooks here. So prior to a plan running, you should be checking for these dangerous resources like null resources and remote providers that are being used, unsafe built-in functions like that run command that we looked at, right? And we can create custom code to check for that or static code analysis tools. And then we have this sort of pipeline that will actually stop your plans from running if found. You can also then establish a mechanism for admins to actually look to see, hey, was that resource legitimate? Did someone actually need to go and use that resource for a legitimate use case? If so, then allow it to move through. Okay, elephant in the room here. We put some mitigations in place to reduce the impact of our pre-merge RCE use cases, but we didn't actually stop it, did we? Only the read-based credentials are accessible now, but they are still accessible. So if we had the opportunity to sort of think and snap our fingers or find ourselves in the seat of the engineers building these tools, what else could we do? And I have some ideas. So for the GitHub side of things, how great would it be to have granular access control for the repository settings, such that what we could say is, hey, if anyone's trying to go and make changes to those protected file paths, .github workflows, .buildKite pipelines, and they're not part of a given set of collaborators, don't allow any sort of configs from actually working. Block those things, right? And we would have to block them on push, which is not something that is actually supported today. Is not actually supported at the time of this slide that I made, spoiler alert. So we know that GitHub supports on push events because if you were to use something like GitHub's advanced security, their secret scanning tools are actually using on push functionality. So we know that it's supported, we just don't have access to actually write on push based event triggers. And the last thing I'll say is on the last bullet here for granularly scoping of GitHub secrets, One thing I didn't mention is your org secrets by default are accessible to all repositories, but you can actually create an affinity on a repo by repo basis. However, if you're going to be using GitHub environments, there is no scoping of existing secrets to those environments, which basically means you have to rotate all of your secrets to migrate to using them, and it's not a great quality of life. Why don't we have the ability to sort of say, hey, this existing repo secret is actually only allowed in this environment? That would be a great addition to have. Same is true for BuildKite, we just talked about that. Okay, and this is actually something that I thought was pretty interesting and pretty novel. It's taking a page from Kubernetes. So if you're familiar with admission control, the way that this works in Kubernetes is, hey, any sort of resources that are being deployed to your environment can instead be sent to this service that runs, and it actually checks the configuration to see whether or not it should be deployed. The opportunity to create admission controller-like functionality for our CI/CD tools, I think, exists, at least for all the ones that we've looked at. And we can see some of the examples of them here. So for GitHub Actions, you can use custom deployment protection rules. You can use run tasks from Terraform, which have existed for a while, but did not support pre-plan based functionality. Run tasks are basically like Sentinel policies, if you're familiar with those. And they would always run prior to an apply, but not to a plan. They do now. And with BuildKite, we can use agent hooks. So what would this look like hypothetically? What we can use is this custom deployment protection rule, like I mentioned, works with GitHub environments, such that when you go and create a change, like a push to a given repository, like we've seen in our sort of workflows, on push, it will send that request to wherever you want. So in this case, it could be a GitHub app that you've deployed. And that GitHub app could then make some sort of custom logic that says, hey, is the user who's making this change allowed to make this change? And if the answer is yes, allow that to move through. And if no, deny it in the same way that we saw the environment fail with this innocent looking file example that we saw a couple slides ago. Similar kind of functionality does exist in BuildKite. It's not as nice, I'll say. It's using all of the sort of bootstrapping layers that exist when you create a runner. So this is basically how you've had to do all this functionality in BuildKite prior to clusters existing. And so this is basically like using initd for all of your functionality, which is not great. And I would probably urge a better way to manage this stuff. But if you needed to, you could probably do analogous type functionality with lifecycle hooks. Here's an example of the run tasks that exist. This is pulled from HashiCorp's documentation. We can see that now pre-plan does exist. So if we actually could create our own run task or look to the industry for actually having something that can go and look for unsafe policies. There are a lot of security companies that do have run task-based modules. Most of them are behind paywalls, and I could not try them myself. But all the documentation seemed to suggest of the ones that I looked at that they still run only prior to an apply and not prior to plan. If such things do exist, I'd love to hear about them if anyone knows. But this is actually where we can actually put this implementation for our Terraform Enterprise and Terraform Cloud deployments. All right. The last thing that I want to talk about is just days old. And had me scrambling to put this slide in, so it doesn't look quite as good. But basically, if we go back a couple slides here to this suggestion of granular access control and event trigger support, back in April, we actually got something from GitHub that is now in beta called push rule sets. And push rule sets actually do basically that. What it allows you to do, either at the repo or org level, is define restricted file paths. So for example, .github workflows or .buildkite paths. And you can set approvers that can actually make changes to those file paths. So in this case, we can see the bypass list allows repo admins and org admins to be able to make changes to this location. And then once you activate it, anyone else, it will fail and you actually won't be able to go and trigger GitHub Actions or trigger anything based on that. In fact, you won't even be able to push changes that violate this. So it's even before any of the other triggers that might occur. Now, if you're afraid of that breaking anything, which is quite reasonable because it's still in beta, you can put things in evaluate mode and you can actually see over time what things would fail so that you can go back and take a look and create granular one-to-one based rule sets that say, hey, this team or this set of individuals can go and make changes to this specific GitHub Actions workflow or this specific pipeline. And that way you can create this sort of granular access control that we're looking for. Okay. Only a couple minutes left here, so kind of the main takeaways. First and foremost, findings are still exploitable today. We do have some mitigations in place, so if you're not actually using those mitigations, definitely take a look at how best they fit in your organization. And you can do so obviously by reading the documentation. I'm not the first person to find all of these problems, but seeing that they are applicable across all of the tools that we've talked about, and probably more that I haven't looked at, kind of indicates to us, right, that our industry and the vendors that are supplying these services have not yet found a clear paved path forward for solving these problems. And it's up to us as practitioners, I think, to innovate here and kind of actually find out the right way for dealing with these problems. And so with that, I would say thank you very much for coming.
Okay, thank you very much, Mike. Really appreciate it. We do have time for questions. We have about 4 minutes for questions.
Awesome.
So I will share them here. First from an anonymous questioner. The risk here seems to be stemming primarily from malicious insiders. Do you see an external threat as well?
The external threat is probably in the open source community, where any sort of configuration that you might have on open source repos or public repos. I do think that this is very applicable to the insider though, right? When all of your engineering force can do something, it means it's much easier for an attacker to get access to any engineer versus one targeted admin or something along those lines.
Okay. Next question from Frenchie. How would pback work in environments with merged queues or stacked branches?
So if I understand how merge queues work, they are particularly for queuing merges themselves and not necessarily prior, the PRs and things that are triggering beforehand. So I don't think that changes anything there. For feature branches, it might change a little bit in that like the feature branch to another protected branch is probably a bit more locked down, and that's probably safer, probably not applicable to this use case. But I do think that the individual who's pushing to an unprotected branch prior to the merge queue or prior to the protected branch, probably still capable of doing whatever is possible there.
Thank you. And next question, if you already have access to the repo to edit the Terraform file, what's to stop you from just editing, say, a Jenkins file?
Well, I'm not sure necessarily. I mean, maybe the question applies to, like, is Jenkins impacted here? Maybe is the question, and perhaps it is. It's not one of the tools that I've looked at, but the Terraform files themselves don't follow the same pattern as the GitHub Actions and BuildKite configs. You're not actually modifying a configuration file for Terraform. You're just adding new resources for Terraform, and that's creating dry runs. So it's a little different than the GitHub Actions and the GitHub or in the BuildKite use cases. Whoever asked that, if you want to catch me outside, and that sounds like a threat.
Stephen S.
Stephen, if you wanted to chat more in the hallway, I'd love to learn more about that.
And then finally, Frenchie asks, have you always had such a husky baritone voice, or have you received professional voice coaching?
Yes, last 3 days it's come into fruition here.
Thank you, Frenchie, for that question. All right. Thanks, everybody, for being here. Thank you so much, Mike, for this awesome talk. I have a prize for you, a special parting gift. Not a parting gift, a special thank you gift.
Thank you
From
so much.
Socket Security. Please go to their booth.